Hello, everyone. Welcome back to another mathematics session. Oni Macleod is the name, and for today's class, we will be solving quadratic equation. Now, the method that we'll be using today to solve quadratic equation is completing the square. So we want to solve quadratic equation by completing the square. Now, in order for us to solve quadratic equation using completing the square, we first must be able to complete the square as it relates to a quadratic equation. Now, when we talk about completing the square, some person might think about geometry or measurement, so to speak. So what we're going to do today is that we're going to concentrate a little bit on completing the square. First, we're going to use geometry to really look at it. Now, when we say using geometry or measurement to complete the square, what is it that we're actually talking about? We're going to be using what is called algebraic tiles, to represent the different terms that we have on the board. We're going to use algebraic tiles to represent the different terms we have on the board. Now, as it relates to our algebraic tiles, the first thing that we're going to be using is a square. Now, when you look at that, you'll see a square there. Sorry, we have our square there. Now, if you notice that we have our blue square. Now, it is blue because it is representing this term here. And this term is a positive term, so we have it in blue. If it was a negative term, then we would have it in red. What we'll be using also is that we'll be using rectangles. If you notice there, that the height of that little rectangle there would have been the same as the square. So if I should use x to represent one side of the square, then it simply means that the rectangle, the height of the rectangle there would have been x just the same. Now, the width of the rectangle, however, we're going to use it as 1 unit. Whatever the unit may be, we're using it to represent 1 unit. Now, also, if we had, say, a negative here, then the rectangle would have been in red. All right, so we would have the rectangle in red. Well, you would have seen a little one, this little one here. This is just a unit square. And again, it is in red, and that would be representing the constant term. And if the constant term is negative, then we would have the red unit squares there. If it was positive, however, then we would end up with a blue one. All right? So let's go again. If it is blue, then it represents positive. If it is red, then negative. All right? So we have the square to represent the square term, and we are using rectangles to represent the B term, so to speak. And those square units, we're using it to represent the constant term. Now, if you notice here, we have x squared here. We have x squared. Okay, so I'm going to remove these quickly. So I have x squared, so I could actually leave it like that. So we say that part would have been x, and that would also be x. Now, notice here we have positive 4x. So since it's positive 4x, we're going to now use some rectangles to represent our positive 4x. Good. So we have it looking like that. Good. Now, here we end up with negative 5. And that would have been the units. So we end up with negative 5. So this quadratic here is being represented using geometry, using shapes to represent it. So here we start with the x squared, and now we have our rectangles. And then we have our 5 unit squares. Notice they're all in red because this is negative. These 4, they are in blue because we have these to be positive, and this is also positive, so it's in blue. Now, our range, we're going to rearrange them so that we end up with one big square. We're going to rearrange it so that we end up with one big square. Now, what I normally say to students is that when you see that those red ones, which is a negative, kind of view it as if they are missing. They are not there. Good, they are missing. So now it's time for us to rearrange. So since we're going to rearrange them, I'm going to just take this out. I need this. I need this. So we're going to rearrange them now. So let me just go to this part here. So I'm going to take this so that you can see that clearly. So I put my large square there. Good. So with that, I'm going to now arrange the rectangles now so that we form a square. So I'm going to have my rectangle place here. And I'm going to place another one here. Now I'm going to place one here because we want to form a square. And if we continue with it going out like that, then that would be like a rectangle. So we're arranging it so that it forms a square. So I have another one here. So now I arrange my algebra tiles and it is looking like that. But as it is there, we still haven't gotten our square just yet, because if you notice that this part here, we need something in this part in order to complete the square. Now, notice here that we need to place some unit squares in there. How many unit squares would you need here? Then that would have been 1, 2, 3, and that now would make it to be 4 unit squares in there. Now, when I look at that, I realize that that now is a square where we have the measurement here would have been x. We say that these are 1 unit in terms of the width. So that would have been 1 and 1. That would have been x. This would have been 1 and 1. The height of the rectangle is the same height as the square. So that would have been x. Here now we have our units. So this would have been 1 and 1. Good. So the length of this side of the square would have been x plus 1 plus 1. So the length of this side of the square would have been x plus 1 plus 1. So I could rewrite it as x plus 2. Let's look at this side of the square. This would have been x plus 1 plus 1. And if you check all the sides, you'll realize there that we end up with the same measurement on all the sides. Good? So you're convinced that this arrangement would no doubt make that be a square. Now, what if I ask you now to find the area of the square? Good? So the area here of square is equal to L squared or S squared. Length times length, side times side. Now, what would be the length of this part of the square? Very good. That would have been x plus 2. Now, because the length of the square is a binomial expression, because it is a binomial expression, it consists two terms. In this case, we're going to be using brackets. So that's one side. The next side would have been x plus 2. All right. Now, if you notice here that this would have given you the area of the entire thing. But remember, I said to you earlier that the red ones, we're going to view them as if they are missing. They are not there. So let's look at it. This piece, we cannot involve this piece in our area because we say it's like it is missing. So since it's already involved in this, it simply means that we now have to look at all of those red ones that are actually missing. So how many red ones do we have that would be missing? Good. So we have 1, 2, 3, 4 down here, plus the 5 that is up here. So in all, we will end up having 9 that is missing. So I could write this now as I'm going to take out my 9 there. So I could write the area now as x plus 2. If you notice that we have the same thing in both brackets. If we notice, we have the same thing in both brackets. So we could end up writing it as x plus 2 all squared minus 9. Now notice this that we have here is writing it the quadratic in the complete in the square form. It is the area of the entire thing minus the missing part, which is 5 here and 4 there. Now, whenever we write a quadratic expression in this form, we say that it is written in the complete in the square form or the vertex form. Now, if it is written like this, then we can always use this to solve the equation because we could equate it to 0. So this is just one way that we could actually use to complete the square. We could use our geometry. We could use our shapes. All right, so we use our algebra tiles and we would now complete the square. However, you're not going to be able to take your algebra tiles inside of the exam. You're not going to be able to take your algebra tiles in there. Therefore, there must be some other way that we can actually complete the square. So let's look at that. Get rid of this quickly. And so I'm going to clean all of this. And we're going to be looking at the completing the square. Now, before we start looking at this, let me just say this to you, that the general form of completing a square is written as a into x plus h all squared plus k. Or we could write it as plus or minus, plus or minus. All right, we could write it that way. So we want to write this so that it looks like this. Remember, we did it before where we use the geometry, we use our shapes to find the area and we see what that was. So let's see what we can do with this. All right, now there are a few steps that you need to follow. Very, very simple steps to complete the square. The first step I would want you to do is to bracket your two variable terms. That is equal to 0. So we bracket our variable terms. Now, in this case, the coefficient of x squared is 1. So we can go ahead and bracket the two variable terms. When it is not 1, there's something that we need to do in order to get it to be 1. Now, let's look at this. Now, in order to complete the square for this thing, what we're going to do here is to find half of the b term, half of the coefficient of x, which would have been 4. Good? Half of 4 is going to be 2. Now, having done that, half of the b term, which is 4, then we're going to square it. We're going to square that. So when I find that, I'm going to end up with 2 squared, and that will end up giving me 4. Now, having done that, I am now going to add this 4 inside my bracket. I'm going to add the 4 inside the bracket. Now, notice here that I will go ahead and I will say x squared plus 4x plus 4 minus 5. Now, here, because I am actually adding something to the expression, because I'm adding something to this expression, I don't want to change the expression. I want it to remain the same thing as what we have up here. So because we're adding this 4 here, we need to also subtract. Now, what I want you to understand here is that in this case, I'm going to subtract 4. I'm going to subtract 4. And I keep saying in this case. Later on, you will see why I say in this case. Now, if I factorize what is inside here and simplify what is out here, then I would end up having it looking like this. So let's see what happens. If I factorize this from our factorization that we learned before, x and x, 2 and 2, the cross product here would give me 2x. That would also give me 2x. Now, what do I need from these two? I need positive 4x. So that would have been positive 4x. So both of them must be positive. So that will be positive, and that also will be positive. Remember, the horizontal arrangement would be our factors. So we end up with x plus 2 times x plus 2. When I simplify this part now, I end up with negative 9. And that is equal to 0. Now, remember here that since we have the same thing in both brackets, then we can now write it as x plus 2 all squared minus 9. And that would now equal to 0. So notice we end up with the same thing, but we're now doing it the algebraic way. And students, I just want you to understand here that completing the square, to complete the square for a quadratic expression is really a times a perfect square, a times a perfect square, plus or minus a constant. To complete the square is really a times a perfect square, plus or minus a constant. Now, let's look at this. This is now your perfect square. This is your perfect square. But what would A be right here? Good. In this case, A would be 1. Good. Now, notice it is A times a perfect square in this case, minus a constant, and is equal to 0. So it is now written in the complete in square form. We could now go a little bit further to solve this equation. However, we're going to leave it for a little while, and then we're going to come back and solve this equation. So we're going to look at another one. We're going to complete the square for that one, and then after which we can come back here and solve this equation. So let me get rid of this part. We get back there. Don't worry yourself about it. Let's say we have 2x squared plus 4x minus 3. Now you're asked to complete the square for this. Now if you notice the one that we did before, that the coefficient, the a term was 1. The a term was 1. And that makes life much, much easier for us when the a term is 1. Good? Now, if it was a case that you were to use the algebraic tiles to work this out, what you would end up doing is that you would only use one of those x squared. That x squared that you would use, this shape, this square that you use to represent the x squared, you would not use both of them. What you would use is 1, and then basically you would divide all of this into, you would complete the square for 1, and then at the end of the day, you multiply your answer by 2. That's what you would be doing. So to make life easier for us, we want to make the coefficient of x squared to be 1. In order to do that, again I say bracket those two terms. Now, I want the coefficient of x squared to be 1. What do I need to do? I need to factor out this a term, which is 2. So I'm going to factor out the a term. So 2x squared divided by 2 will end up with x squared plus 2x into 4x will end up giving me 2x. And I will close my bracket and I minus 3 from that. Now, remember the set that we looked at when the coefficient of a is 1, then we're going to find half of the x coefficient and then square it. We're going to find half of the x coefficient and square it. We can only do that when the coefficient of x squared is 1. So when we factor out our 2 here, we actually made the coefficient to be 1. So we're concentrating on what is inside the bracket now. So half of the coefficient of the x term, so that would have been half of 2, and then I'm going to square it. Now, half of 2 will give me 1. 1 squared will give me 1. Now, this one, I'm going to add it inside of the bracket. I'm going to add it inside here. So it ends up giving me x squared plus 2x plus 1. I have that inside the bracket. Minus 3. Now, this part you need to pay close attention to, because here we actually add 1 inside the bracket. Here we add 1 inside the bracket. Now the question is, will I now go and subtract 1? In this case, no, because this is what is happening. This one, or everything inside this bracket here, is now affected by this coefficient, this 2 here. Everything inside this bracket is now affected by the 2 that is out there. So what is it that we're going to subtract here is going to be 2 times whatever we add inside. The one before, we didn't need to do that because we had 1 there. And 1 times 4 would end up giving me 4 just the same. So we could just go ahead and subtract because the numerical value here was 1. So let's work this out now. We're going to factorize what is inside here and simplify what is out here. So to factorize that, remember we could write it as x and x. We have 1 and 1. Go across. So that will give me x. That will give me x. But what do I need? I need 2x. So both of them must be positive. So I add those. So that's positive and that's positive. Now, the horizontal arrangement would have been your factors. So I can now write it as 2 open bracket x plus 1 into x plus 1 minus, here you owe 3, you owe 2, so you end up owing 5. All right. Now here we have x plus 1 times x plus 1. That's a perfect square. So I can now write it as 2 into x plus 1 all squared minus 5. So there we have it. We have now written this expression at the top here in the completing the square form. Now all we're saying here is that this is the same thing as this. If I should go and expand my brackets and simplify, then I would get this as my answer. All right, so that's it as it relates to the completing the square. But how do we now use completing the square to solve a quadratic equation? Now, we could start with this one. However, this one, we need some calculators for this for sure. So what we're going to do here is to go back to the other one, which will make life a little bit easier in terms of explanation. All right. So we had x squared plus 4x minus 5 equals to 0. All right, so we want to use completing the square to solve it. So again, as was mentioned, we have to write this in the completing the square form first. So let's go. Let's put the 1 there. I want all of you to now look what is happening. We put the 1 there, so we have take out 1, it won't really affect it. So we have x squared plus 4x minus 5 equals to 0. Notice here, 1 divided into x squared will give me x squared. 1 divided into 4x will end up giving me 4x minus 5. Now the next step is to find half of the coefficient of x and then square it. Half of 4 will give me 2. When I square it, I end up getting 4. So 1 into x squared plus 4x plus 4 minus 5. Now, notice here that whatever we add inside here, we must now multiply by what is out here. But 1 times 4 will end up giving me 4. So I can just minus 4 there, and that is equal to 0. Now, you might ask the question, why is it that we found half of the coefficient of x and then square it? What we want to do is to turn inside the bracket here into a perfect square. We want to turn this part here into a perfect square. Good? So when you turn it into a perfect square, you know you have that part. But because you're adding something to the expression, we have to subtract in order to have the expression remain the same. So we can go and factorize. So let's go quickly. We already know that this will end up to give you x plus 2 all squared minus 9. And that is now equal to 0. Now, in solving this, we're going to transpose and make x the subject. We're going to transpose and make x the subject. But at this stage, you should know the order of arithmetic. And the order of arithmetic, we use lambdas to represent the order of arithmetic. Good? Now, remove brackets, remove powers, multiply, divide, add, subtract. We know all about that. However, when you're transposing, we're doing the opposite. What you do last for the order of arithmetic is what you do first when you're transposing. It's simple. It's like going to school in the morning. Your socks and your shoe. Going to school in the morning, you put on your socks first, followed by your shoe. Right? But what about when you come back home in the evening? You don't take off your socks first. No. You take off your shoe, then the sock. That's what is happening when it comes on to transposition when compared to the order of arithmetic. So I could easily write it down as sod mouth. So what did we do last down here? Subtract. That's the part that we're going to concentrate on first when you're transposing. So let's go. So here is the subtraction part. We're going to transpose this part first. So since we're subtracting here, we're going to end up adding 9 to both sides. So we end up with x plus 2 all squared. And that is going to equal, if I add 9 here, it will cancel out this. And I'm going to add 9 over here. So I end up with 9. Now what next? What next? Now, remember we say we're using sod mouth. So subtract. We look at that part. Addition. You're seeing an addition here, but this addition is inside the bracket. So we can't look at that just yet. So division. There's no division here. What next? Multiplication. Okay, here's the multiplication right here. So I would now get rid of this term right here. But because this is 1, if I divide, it really won't change anything. So, and I divide over here, it won't change anything. So I end up back with x plus 2 all squared is equal to 9. Okay, so we finish with that multiplication part. Now, we're now on to the power part, the exponent part. Now, it simply means that we need to get rid of this square. Now, to get rid of the square, we're going to have to take the square root of both sides. So it's going to be x squared plus, sorry, not x squared, x plus 2 all squared equal to 9. Equals to 9. So I'm going to take the square root of that part. And I'm going to take the square root of that part. However, when you're transposing a square, it must be plus or minus. So I take the square root of that part, and then it becomes plus or minus the square root of that. Now you might ask the question, why is it that I have to put plus or minus there? Let's look at this. X squared is equal to 4. Now, if I ask you, what's the value of x? So that when I square x, it gives us 4. Then I know that many of you would be tempted to say, oh, it's 2. Not that you're incorrect, because if I square 2, it is going to give me 4. But what if I square -2? What will that end up giving us? That will end up giving us 4 just the same. So what we're saying is that when you're squaring a number, whether the number is going to be a positive number or a negative number, when you square that number, it is going to end up giving you a positive answer. So therefore, we can write this as x squared, take the square root of that, equal to plus or minus the square root of that. The square will cancel that, so you're left with x, and x is going to equal to either +2 or -2. Because when I square -2, it is going to give me 4 just the same. That's the principle that we're applying right here. So that would cancel that. I'm now left with x plus 2 equal to plus or minus, when I find the square root of 9, that would end up giving me 3. Square root of 9, that would end up giving me 3. Now it's now time for me to concentrate on what is inside the bracket, which is x plus 2. So I need to get rid of this 2. Since I'm adding here, all I need to do is to subtract 2 from both sides. So this will end up giving me x equal to plus or minus 3 minus 2. So it is going to be positive or -3 minus 2. So it's x equal to positive or -3 minus 2. Now in this case, all we need to do here is to separate these signs here. So I could write it as x is equal to +3 minus 2, and this would end up giving me 1 as the answer. Or I could write it as x is equal to -3 minus 2. You owe 3, you owe 2, so therefore you would end up owing 5. So there you have it. We will have completed the square as it relates to the quadratic equation. And then after we complete the square, we now went ahead and transposed, and we now reach to the point where we end up finding the values of x. We end up finding the values of x. So we could actually look at maybe one more. We could look at one more, just one more. So let's look at this one quickly. If I have x squared plus, and let me use minus 12x, and this now would give me minus 7. So let's look at that one and see if we could solve it quickly using the completing the square. Now, first we want to complete the square here. Now, since A is 1, it makes life easy for us. So again, we could factor out A is 1. It really won't change anything, but we're going to just do it just the same. So we factor out 1. So x squared divided by 1 will give me x squared minus, here 1 into that will give me 12x, close my bracket, minus 7. All right. All right. I think I want to change this part, and I'm going to put 6 there because I want you to be able to just using perfect square numbers. All right. Now, so I have it looking like that. So what we want to do now is to turn what is inside here into a perfect square. Now to turn this part into a perfect square, again, we find half of the coefficient of x, which is half of -6, and then we square it. Half of -6 will give me -3. When I square that, it is going to give me +9. Now, if I add this inside my bracket, what is inside there becomes a perfect square. So I'm going to add this inside the bracket. So this now becomes x squared minus 6x plus 9 minus 7. Now remember that I'm going to have to subtract, because since I add something inside here, I have to subtract something out here so that it remains to be the same thing as what we have up here. So in this case, what am I going to subtract? It is going to be 1 times 9. But remember, it won't really change anything because it's 1. But you have to be conscious of the fact that whatsoever is here, when you add what a number inside the bracket, it is affected by what is out here. Therefore, what is it that we're going to subtract here is going to be the a value here times whatever you add inside the bracket. So we can factorize in here and simplify what is out here. So let's factorize quickly. X. For this, I'm going to use 3 and 3. So here, the cross product will give me 3x. That will give me 3x. What do I need? I need -6x from it. Now, to get -6x, it means that this should be negative and that should be negative. So that's negative and that's negative. So I can now write it as 1, open bracket, x minus 3 times x minus 3. I need to simplify what is out here now. So this is going to give me -16, and that is now equal to 0. As you notice, we have the same thing in both brackets. So this now ends up to be x minus 3 all squared minus 16, and that is now equals to 0. So we have it now in the complete in the square form. It's just for us now to go ahead now, transpose, and make x the subject, and that would now end up giving us the solution. So let's go. Getting rid of the 16 here. Since we are subtracting, we're going to add it to both sides. So this becomes 1, open bracket, x minus 3 all squared, and that is going to equal to 16. The next step is that we're going to have to get rid of the numerical value here. As we said before, because it is 1, it really won't affect anything. So if I divide this side by 1, divide that side by 1, it would end up giving you the same thing. So it end up with x minus 3 all squared, and that is going to equal to 16. It's time for us to get rid of the square. So we're going to take the square root of this side, x minus 3 all squared, and that is going to equal to, you remember what we said before? This case is going to be plus or minus the square root of 16. Square root cancel the square, so we end up with x minus 3, and this is now equal to positive or negative 4. The last thing to do here is to get rid of this 3. Since we're subtracting it here, we're going to add it to both sides. So we end up with x is equal to positive or negative 4 plus 3. Again, we go ahead and we separate these signs and work them separately. So it's going to be x equal to positive 4 plus 3. In this case, x is going to give us 7. Or x is equal to negative 4 plus 3. In this case, we owe 4, but we have 3. So x is going to equal to negative 1. All right? So again, we would have solved this quadratic equation using completing the square. Now, all you need to do, students, is just practice as it relates to completing a square. All right? There are different ways that teachers would bring it across to you. And whichever way you feel comfortable with, you go ahead and you practice those stuff. And then you must also practice your transposition in order to solve the quadratic equation using completing the square. Now, this is where we'll have to end for today's class. So I look forward to see you again, where we could use completing the square to determine other stuff other than the solution or the roots of the quadratic equation. So the completing the square, we could use it to determine other stuff. So looking forward to see you then.
All right, good. Thank you.
You're welcome.